it's 6 o'clock, and I want to thank you all for coming, especially with kind of a little bit of the weather that we're starting to get. We appreciate your attendance. My name is Todd Andrus. I'm the Regional Business Manager for Pacific Power, and we're very pleased to introduce you to a person who has over 40 years of experience in the energy business and understanding how to help individuals such as yourselves save and work on energy efficiency and stuff. I've known Buzz for approximately a year myself. I've attended a couple of his presentations. I will tell you that they're always, you learn something every time. Over and over and over again, I always pick up something new.
Thanks.
So anyway, we're very honored to have Buzz Thielemann, our consultant, to come here and present some ideas for you. And hopefully we'll pick up a few and take them and put those to good use for you individually. So it's my pleasure to welcome Buzz.
Okay, thank you, Todd. And again, thank you everybody for being here. I really applaud you taking the time away from your schedules to be here. And this is a program, this Watt Smart program is an outreach customer information program by Pacific Power. It's part of a series, and I think it's really good. If you look at how you use power, the most significant thing in it is how you use it. And so it's really, really aimed at customer education. And I have done this for a very long time. And I've been an instructor for Pacific Power, even for the Army and whatever, and I've learned a lot. And I also, for public power, I've done it, and it even affects how I dress. And I always used to dress in white khakis, and I always would have this El Marco. I used to put little tents up there. You'd write your name, Doris or Jim or anything. And I was up there and I was flipping my pen just like that, and I had this El Marco, and it landed right on my pants. And this is in the first 10 seconds. And it put, in the most embarrassing, put a jag right on my crotch. And the whole class went silent. I mean, it was 35 people in there, and I'm going, what am I going to do? I have 2 days of teaching. This is how I started out. And there was this guy in the back, kind of a hippie-looking guy with long hair, dead silent, and he just goes, dude. And that's how the whole thing. Since that whole time, honestly, I always wear dark pants. Always wear dark pants. But I have been a consultant. I've been doing this, and I really enjoy it. And this is a small, informal group. So if you have a question, just interrupt me. Can you get the door, please? And because you have a question, generally everybody else does. And I am a consultant, and I flare at that a little bit because I came from a farming community in Sunnyside, Washington. I don't know if you know where that is. And the story is about this farmer. And I told one time as a consultant, he goes, you really want, let me tell you about a consultant. He said, this guy was a rancher, and he had thousands and thousands of sheep. And all of a sudden, there's quietness, and this SUV comes over the hill, and it's a trail of dust. It comes right up to, and the farmer's sitting on his quad there, and he's watching all the sheep. And the guy comes up with the SUV, and he says, hey, are you a gambling man? And the farmer looks at him and says, hey, if you're a farmer, you're a rancher, you're a gambling man. Yeah, you have to be, otherwise you're going to. He says, yeah, I'm a gambling man. The young man looks at him and says, well, I'll tell you what, if I can tell you exactly how many sheep you have and do it in less than a minute. He said, can I have one of them? And he goes, I'll take that bet. There's thousands of sheep up there. And the guy pulls out his GPS, pulls out a satellite dish, he gets his little laptop, and in a couple of calculations, it comes back and says, sir, you have exactly 4,532 sheep. And the rancher goes, unbelievable. He says, pick out your animals. The guy's loading it up. The rancher comes over and says, I got to ask you a question. He said, are you a gambling man? And the guy says, well, of course I guess it's only fair. If you are, I am too. And he says, if I can tell you exactly what you are, can I have my animal back? And he says, yeah, I guess so. He says, easy, you're a consultant. And he goes, how did you know that? He said, 1, you came unannounced. 2, you told me something I already knew. And 3, you just loaded up my dog. So when people say they're a consultant, you gotta, you kind of wonder if it's a two-edged sword. But anyway, I've done this for a long time. I am the president of this company called Oregon Energy Green. We do contracting services, and I'm thrilled to do this one for Pacific Power. I actually worked for Pacific Power for 27 years in marketing and technical service. I basically was a troubleshooter, is what I was. Certified energy manager. I am a duck. Actually, this has taken me so far into infrared photography. I wrote a book called The Hunt for Allies, and it's right now on Amazon. It's doing pretty well there, and that's fun. I'm married and have 2 sons, lived in Medford for 30 years, over 30 years now. I have done this, when I started adding it up, I've done it now for 44 years. Started in 1971, it's amazing how time goes by. So I've done it for a long time, and I've seen the things change over time too, and the messages of the power company, and the messages that they're going to give to you. This one actually, and Todd, I got this out of the bin bulletin. It was published in August 14, 1973, and the character that Pacific Power had was called Colonel what's his name, but his slogan was, use what you need, but save all you can. And it still is true today. And a lot of people will ask the power company, say, why do you want people to use less energy? Why do you want to conserve? And here's the easiest answer. If I had 10 houses, and each one could use 10% less, I'd have enough energy to serve that 11th house without having to build a dam with a new power plant or anything else. And so that is the reason why conservation is a big thing for you, and it's a big thing for the utility as well. Small changes can make very big energy savings on how you use it, and that's what we're going to talk about today. The most significant element in energy use is you. And when I started in Albany, Oregon, I remember this. It was an apartment complex, and there was one couple living right here, and another couple living right here. The couple here was about 80 years old, and the couple here was about 30. And the apartments were identical, they shared the same walls. And I went there because there was a high bill question. Why was the bill so high? Well, it turned out the people on the older public had to have it, they kept it at 80 degrees. And one of the things that happens for every degree over 70 raises your bill about 3.1%. Feel free to write down any of this stuff if you'd like. And so their bills were about 30% higher than the ones right next door. So I learned right off, even the houses were the same, the heating systems were the same, how they used it was really, really, really critical, and their bills were consistently running about 30% higher. But I want to talk about no-cost, low-cost things that you can do. Because yes, you can buy new heat pumps, you can re-insulate your house, you can do a lot of things like that. I welcome. But there's also no low-cost things you can do. And the first little message, you can't control what you can't measure. Can't control. If you didn't have an odometer on your car, and you couldn't figure out gas mileage, how would you really know unless, just how much, until you got to the pump, how you were doing? So that's the first thing we want to talk about, is what can you measure? And one of those things is the power bill itself. Understand your power bill. I like how Pacific Power does it. This chart on the right here, I hope you can see it. It shows, the bar graphs of how many kilowatt hours you use today. Now this looks very, very common for somebody that has electric heat. You expect it to happen. But what all of a sudden, if you had a bar right in the center right here, what would you think? What would you think? Has your ductwork fallen off? Maybe you have a hot water leak. What is it? And I encourage people to look at it. I encourage people to look at it. Because this really is the barometer that you have to say, you compare it to the same month, the previous year, or recent months on similar conditions. It's a very good barometer of what's happening at your home. I want to start here. This might be a little bit blinding, but I want to show this to you. Okay. That's 10 100-watt light bulbs. 10 100-watt light bulbs. And the reason why I show that is this, is that if I take 10 times 100, that's 1,000 watts. And Pacific Power sends you energy, and they measure it in kilowatts. Kilo is Greek for 1,000. So when you see, if I turn this on, this is 1 kW, or I've got 1,000 watts. If I divided it by 1,000, it would be 1 kW. I want to show you something else here. I've done this in particular. Do all those light bulbs look the same? Sir, what do you think? What looks different? This one up here?
Yep.
It's a little dimmer, right? Okay. And what I want to show you, this is just when you buy light bulbs, and this is kind of an interesting display because it's hard to even find a 100-watt light bulb now. And I treasure these because I wonder if I ever lose them, what's going to happen. But these light bulbs are all the same right here. And what they are is the standard 100-watt light bulb. And a standard 100-watt light bulb has a life of 750 hours. 750 hours. Now, that is not very long. If you take 24 hours a day times 30 days, that's 720. In other words, a standard light bulb, if you turned it on and let it run a month, it's just about at its end of the life. And I remember this, Todd, when I was in Sunnyside and we had a brand new subdivision there. And got a call from a customer and he said, hey, you must have a voltage problem. All my lights are, burning out. And it was a brand new house. Well, what happened? All those lights were put in new. And it was about 3 months later and they were all reaching their end of population. We didn't need to send a service man out there to do a voltage check. They were coming at the end of the life. But let's say, you have a house that's 10 years old, you've changed one out, changed another one. Pretty soon it's just one after another. But the standard light bulb only lasts about 750 hours. That's 1 month. Now, this one right here is a 5,000, I'm going to turn this off so I don't blind you guys. But that one is called a long life light bulb. And if you can see this, it's okay. Is this a dry marker, Amber? So a light bulb works like this. It's called a stanchion there. It's usually made out of glass. And then it's got on here a filament in here, like that. And when you turn that on, that burns at 4,200 degrees Fahrenheit. That's why you can use it, you can use it in your oven, you can use it in your refrigerator. Nice thing about incandescents is that you can really use them anywhere. Okay, now this is made out of tungsten, and as it gets hot, it boils off there. And have you ever noticed you'll start seeing black on the top of the light bulb? It's from this getting thinner and thinner and thinner. And eventually you turn it on and it'll ever see it flash blue. You ever see that? A lot of people think it's that. It isn't. Right down here in the stanchion, they have a fuse right in there. And you would not, a lot of people, and it blows the fuse because if that blew, they're worried about the glass. And that blue flash is this fuse going. But my point is right here is that if I want to make that light bulb last longer, you know what I do? I make the wire heavier. You make it heavier in there so you get long life but less light. And I remember this because my mom, and she passed away now, but when she was living in Portland, she was like in her 80s. She couldn't get up on a chair to change light bulbs. So I went in and I put all these in there because, Mom, you don't have to change them out. You know what? She hated them because it wasn't enough light. It wasn't light. So the little message on this one is you don't get something for nothing. You either get light on a light bulb and they last about 700 to 1,000 hours, or you put in a heavier filament like that and you get long life and you don't get much light. It's one or the other. So if anyone comes to you, sir, and says, hey, I'm going to sell you these long life light bulbs, reality, hey, what he's selling you is less light. He's selling you less light. Okay. So let's go a little bit further into this. And feel free to stop me at any time because I'll just keep rambling on this. But anyway, so going back to this, 1,000-watt light bulbs, 10 times 100 is 1,000, divided by 1,000 is 1 kW. Sorry. No problem. And on this, so now if I took 10 100-light bulbs and I burned it for an hour, that would be 1 kilowatt hour, 1 kW over an hour. So in other words, right now with Pacific Power's rates, fully loaded, everything in, taxes and everything, 1 kilowatt hour times 11 cents costs you 11 cents. So you can take this right here and you can run it for 1 hour and it's 11 cents. That's what it is. That's the current rate right now. How to read your meter. And I want to talk a little bit about this because I'm talking about you can't measure what you can't control. And do you guys ever go out and look at your electric meter? Do you ever do that? Never do?
A lot of where it just spins.
You just watch it spin. Well, that's why I like to talk about this because, I've had people say, well, how do you bill me? You just come up with a number. Well, we don't come up with a number. We read that meter. And there's two types of meters out there. And one, this is the standard mechanical meter, and I think in this area you still have a lot of those. Okay? And then they also have digital meters too, and they look like this, and it looks like that. And they both do the same thing, and they have to be highly accurate, and we measure them for accuracy. And I want to be just a little bit technical in how we go about reading those. Now, on the one on the left, this one, we read it about every month. Sometimes it doesn't work out that way, you know, like the 30-day falls on a Saturday and Sunday, or it's a holiday, or it's inclement weather, and we don't do it. We try to do them every 30 days. And so all you do is you look at this number here, and you take the reading today, you subtract the previous reading from the current reading, and then you multiply it times about 11 cents, you come up with a bill. On these, it's a little bit different. And let me show you how you do this. Here's a good example. This is right now the current read right here, and this is the previous read. For example, this was a read of July 31st, 2014, and here's the one from July 1. So I had a 30-day billing period here. And so this is kind of interesting. This is how you read it, and meter readers get really, really good at this. You'll notice this hand goes clockwise, this one goes counterclockwise, this goes clockwise, that goes counterclockwise, and this one goes clockwise. And they alternate direction. And the reason they do that, they don't have to have a correcting gear in it. So the first rule, if it's in between two numbers, you always take the smaller of the two. So that's between a 5 or a 6, so it'd be a 5. This one is going to let your eyes go this way. It's past the 9, and that 0 now would be a 10, so it's a 9. Follow that thinking? This one, you let your eyes go this way, and it's almost to the 2, and I know it's not to the 2 because this would have to pass 0. The reason, and you get to look at this very fast, imagine on this dial right here, there's 10 little tick marks. Every time this moves 1, here, this goes 1 little tick mark, 2, second tick mark, 3, 3. So it'd be on the 9th tick mark. So I know it hasn't passed the 2 yet because that hasn't passed 0. Do you follow that thinking? So this would be 5, 9, 1, the eyes go this way, 0, and this one has passed, so I know that's an 8. So it'd be 5, 9, 1, 0, 8. You read them backwards, you write them down backwards like that. And then here was the previous read, 5, 1, 9, 9, 7. So I just subtract the current read, here is the current read, from the previous read, 280 kilowatt hours were used, and right now the cost is about 11 cents, so that'd be $30.80. That's how the whole thing works. Something else that I want to show you how to do, and the reason why I use it, I was a troubleshooter, and I worked with electricians all the time, and these people got a hot tub, and the dealer told them it was going to be $5 a month, and their bill jumped up about $30 to $40. And they came to me and said, why did it do it? The dealer told me it was only going to be $5. Well, it was 11 kW heater, and this is how I proved it to him. And I'd like you to write this down on your, write this formula down, please. Watts equals the number of revolutions times 3600 times K sub H. That's the top. So watts equals number of revolutions times 3600 times K sub H. And then you can divide that by time in seconds. And if you're ever doing any electrical work, this is great. This is great. Now let me show you how it works. I'm going to turn this on. Does somebody have a calculator on them right now? Calculator? Do you have a calculator?
Yep.
Thank you. So watch what happens here. And by the way, so the K sub H is written on your meter. Like even if I pass this around, you can see this as a K sub H of 1. You can pass it. Okay, you pass it around. It's the gear ratio. It's just like if you had a car. Let's say I'm kind of a Chevy guy. Let's say you had a 456 rear end or a 331. You know, you have different gear ratios in your rear end. Meters have different gear ratios too. It's called a register ratio. So that's what it means. And so this is how this formula works. If I turn this on right now, this meter is spinning. And what I'm going to do is I'm going to time it for just 1 revolution. And I screwed that up. Screwed it up again. Here we go. There we go. I'm going to go 2 revolutions on this. 1. 2. So let's this way. I've got, my formula is going to be 2 revolutions times 3,600. 3,600, that's the seconds in an hour, by the way. 60 times 60 is 3,600. Times my register ratio, which is 1.8. And my seconds were 14.2. Can you do that math for me, please?
912.676056.
9, 1 what?
912.
Okay, that's it. So I've got 912 watts, don't I? And what should it have been? 1,000, perfect. You see, and the reason why my voltage is a little bit low here, I'm about 112 volts here, it should be 120. But I like to show that to people, and honestly this is too technical for some, but let's say you want to know exactly what your hot tub is using. You want to know exactly what your air conditioner is pulling. You want to know exactly what that portable heater is using. You can turn off all the breakers, turn that on, time your meter, and it's going to tell you exactly what it's doing. That's a formula, honestly, I showed to some electrician. The electrician came to me and said, Buzz, you can't believe how many gutters I have torn apart and put a clamp on amp meter to figure out the amps, and I could have just timed the meter. So anyway, I want to show that to you because it's a really, really handy tool.
Buzz,
Yes.
can you tell them how to do that with a digital one?
Yes. With a digital one on, where's my digital meter? Oh, the digital meter. What I'll do, in fact, what I'd like to do maybe just when we get through, a digital meter flashes. It's like called a caterpillar on there, and you can watch that caterpillar come on. It goes click, click, click. That's one rev. Click, click, and you count the caterpillar revolutions, and that's how you do it. And when I get through here, anyone wants to see it, I can pull that meter and stick it in there and show you how to do it. Okay? How many meters are they mostly digital in this area, or are they mostly?
We're in the process of changing out the older style, but we're still mostly
Mechanical? Okay. But we can do that right when we get through. Hey, I want to talk about your water heater. The water heater is the second biggest user that you have in your house. It only follows electric heat. Electric heat's #1. But I want to talk about your water heater because it is a big user. They're a fantastic piece of equipment. Here we go. In most families, the water heater is the first or second largest energy consumer in the house. Most water heaters are either electric resistant, in other words, they get hot, have an element in it, or they're natural gas. Electric water heaters can be mounted almost anywhere because they have no exhaust stack. That's the nice thing, you can put them under a stairwell, you can put them in an attic, it doesn't have the, the exhaust stack that you would have if you had a natural gas water heater. Malfunctions in water heating can cause huge increases in energy consumption. An average family of 3 with an electric water heater will use about 500 kilowatt hours a month. That's about $55 right there for water heating. Each additional person adds 100 is how it works out. Because there's more showering, more cooking. Teenagers can add twice as much as an adult. And if we've had teenagers, how long they can stay in the shower, you can understand that. And a baby will do the same. They will use twice as amount because you're doing more washing, whether you do diapers or cleaning, you will use more. Generally, water heaters are set at 120 degrees Fahrenheit unless there is a dishwasher, which generally requires 140 degrees Fahrenheit to dissolve the soap. People would ask me and say, why do you have to keep 140? They say it's for sterilizing. To sterilize, this is a hospital. You got to be 212. You have to boil water to sterilize. 140 is dissolved the soap. And if you ever open up your dishwasher and you see those little white granules, do you ever see that on there? That told you ran out of hot water. It ran out of hot water, and because it's not dissolving the soap. That is a really, really good indicator if you're not dissolving it. And also, there's another factor too, is how hard your water is. If you are in Portland, you have water off the Bull Run Reservoir, very, very soft water, and you can get by at lower temperatures. If you're in Bend, Oregon, or you're on a well, are a lot of people on a well here? No?
City water.
City water. Well can be very, very hard. In Bend, it is very, very hard, and they have to really jack their water heaters up just, to dissolve the soap because it's hard to get suds. So anyway, let's talk about the water heater and parts of it. This is called a pop-off valve on top. Looks like a little hand grenade, and it's a safety device. Because if you ever boil water in here and a thermostat sticks, the thing can explode. And this is a pressure relief valve. And I'm going to read you this story. This came out of Buren, Washington. Water heater explosion damages business in Seattle suburb. Buren, Washington, an exploding water heater shattered the fronts of 3 businesses and a shopping center and injured several people Friday as it rocketed over a Pizza Hut building and a parking lot about a block away. The damage was $750,000. Crews found the people dazed and confused in the parking lot, some with severe burns. The explosion was apparently caused by an electric water heater. The pressure relief valve had been capped. So, little safety device. Pacific Power loves to sell you energy. They love to be part of this community. We want everyone to be safe. As a troubleshooter, I have seen this, where these started to leak and people capped it off. Never do that. Never do that. This is a safety device. If anything goes wrong, it keeps the water heater safe. Gas ones have it, electric have it. Make sure that it's always there. Next thing on there, the drain. And I'm going to point on there, this one, it's right here, and I can't lift this thing up, but it's right down there. If you ever to change your elements on your water heater, like you blow it up, you turn it off electrically, you turn off the water, you open that drain, then you open the pop-off valve, and then the water just drains out. It's just like if I had a Coke bottle and turn it upside down, the water is going to go bloop, bloop. But if I put a hole on the top of that, it's just going to run out, right? And that's how you do it. But the procedure is you turn it off electrically first, then you turn off the cold water to it, and then you open up this to give it air, and you open up the drain and put a garden hose on it and drain it out, and then you can get sediment out of it and you can change out the elements. If that ever starts leaking, what I've found, and the reason why they can start leaking, if you ever drain them out, sometimes a little bit of sediment gets inside that valve and you try to close it and it'll leak. You know what I found really works good? You know, on a soaker hose, you put out on your lawn, they have those little green end caps. You can just put the green end cap right on that thing and that'll just close it off for, pennies. In case that you don't have to throw it away, just put that end cap on it. Dip tubes. The way a water heater works is this. Cold water comes in here and it goes all the way down to the bottom of the tank. It goes all the way down like that. And so cold water comes in, then it heats up, and then it comes out of here. It pulls off the top, goes to the bottom. The reason they want to have it go all the way down to the bottom, it starts the circulation. It's called convection. And what's happening is the hot water all rises to the top, and eventually you get the whole tank warm. But this is what happens on these things, and if this ever happened to you, it's happened to me. My wife's name is Sherry, and I'm like, God, I'm running out of hot water. Did we burn out an element? I couldn't figure it out. And I put a voltmeter, I put a multimeter on the elements, and I was getting continuity. There was no problem with that. And so I pulled out the dip tubes. This is the one that comes with it, by the way. This one I bought at Lowe's or Grover's for $3. Okay, prop. Oh, here we go. These things are very cheap, guys. And this is what comes into it. And it had broken off about like here. And it just disintegrated. And when it did, I was just short cycling. The cold water was going right to the hot water. And they had a recall at A.O. Smith and a lot of them, and they were just disintegrating. And our hot pots looked like the grapes of wrath. I had to rip the thing out. I had it on the front lawn. I'm riding it like a rodeo, and I'm getting all the stuff out of it. So anyway, I want to pass that around. That's what it originally looks like. For just $3.50, you can put this one in, and you can see how much better. Or, if you really want to splurge, you can go all the way to $5 and have a plumber make you one out of copper, which will last the life of the tank, no doubt about it. But I also want to, as you pass this, do you guys notice there is a hole in it, about 6 inches down? Did you guys notice the hole? Why is there a hole in that dip tube?
Pressure.
What's that?
Pressure.
Close, very close. Here is the reason why. You're on a city system here. Now the fire department, you get a doorknob hanger says you're going to be out of water service because they're going to drain the lines. And what they'll do is they open up the fire hydrants and they do it, and all of a sudden, if this ever, you'll hear a sucking sound. Have you ever heard this? When they drain the system and you'll hear, You've heard that? Well, what happens if you left your water heater on? And all of a sudden, it sucked the water out of here, and then all of a sudden that it'd burn the element out, wouldn't it? Because there's no water around it. What that does, as soon as the water gets below that little mark on there, it starts sucking air, and it won't take any more water. That's why they have a little hole in it. So that's a dip tube. If you ever run out of water sometimes, this could be the culprit, and I'll explain a little bit more how to figure that out. Because the cold water is supposed to go all the way down, and then it rises to the top, and it goes out there. Next are the elements. They look like this. There's two of them. There is an upper and a lower. They never go on at the same time. There's an interlock. It either means this one comes on first, and then once it satisfies the temperature up here to give you faster water because it pulls from the top, then it sends the electricity down to the bottom. The reason why they don't come on the same time is the power company. If you see, this is 4,500 watts. So think of this. This is if you walk away with only one thing, this is equal to 4,500 watt light bulbs. 4,500 watt light bulbs. And I want people to think of that because people will say to me, Buzz, you know, I don't know why my bill went up. He said, you know, okay, I did leave that light on the porch all night long. It was 60 watt. And I go in there and here's a drippy hot water faucet. This is if 4,500 watt light bulbs came on when that happened, or when Denise takes too long in the shower, or whatever, you know, that would register because this is equal to 4,500 watt light bulbs. And that's what you should pay attention to. But anyway, so one comes first, the top one comes on, then the bottom one comes on. They don't come on together because if you were on the same transformer, you'd be dimming the lights on everybody's transformer. You'd be dimming the lights, because 9,000 watts, bang, coming on like that, it would dim your lights and it would dim people on the same transformer. And so it's either one or the other. That's how they do it. So you can pass this around and you can see the wattage on it. Let's see. I want to go back. Oh, check valve. Here's something else. You have a new water heater now. This is a check valve. Listen to this. And what happens to stop the migration of heat out of here? They put these little rattle things. It's called a check valve. And it prevents hot water from migrating back to the line when there's no use. I know this is a code thing, drives me nuts. We put a new water heater in it, came with that, and it was in our TV room. And I'm going, Sherry, God, what is that sound? And every time I hear, you know, it'd be a silk part, and I hear rattle, rattle, rattle. And I ended up taking them out, I'll be honest. I insulated line but if you ever hear that sound, that's what it is. It is a little check valve that they're putting over their water heaters now. Insulation, the last one. Used to be tanks were just filled with fiberglass insulation, and that wasn't very good. So we'd wrap them with water, put a wrap around them. On the new water heaters like this, you see this one's foam inside. I don't know if you can see it. You really don't need to do that anymore. The foam is really adequate insulation. But if ever it gets wet and it starts rusting, that's a good time to think, time to get a new water heater. Water heater leaks are expensive. And remember, think about it's 4,500 watt light bulbs coming on. Just 30 drops a minute, so that'd be one every other second. Can you guys see that okay? Should I turn the lights off or are we good? We good? Okay, that's about $2 a month. 60 drops, that's just one every second. It's $4 a month. If you get 90 drops a minute, okay, this is all a minute, that's 310 gallons that goes down the drain, that's $7. If you have 2 a second, it's $9. But if you ever get like a stream coming out of there and then it breaks into that, now we're talking a lot. That's equal to 1,114 gallons a month, and it raised your bill $24. So be very cognizant of water leaks. Hot water leaks, they're expensive. And this is if there is ever a major leak, and this one happened on one. Again, I was in Bend on this one, and Bend is kind of like Lakeview. I mean, it gets cold. And these people were gone, and they broke a hot water pipe under their house. And they weren't even there. But the reality, if you take 4,500 watts, which divided by 1,000, 4.5 kW, times 24 hours, times 30 days, that's 3,240 kilowatt hours times 11 cents, $356 their bill went up. It's a lot. So be very conscious of hot water heating. It's a wonderful thing, but if anything goes wrong with it, it can be expensive. Any questions up at this point? Okay. Types of electric heating and cooling. There's so much to choose from right now. And this is like a standard heat pump that you have. This is an, oops, go back here. This is an electric furnace. Electric furnace is a box with heating coils into it. They get red hot like that and circulates air through it. A heat, boy, Buzzy. The heat pump runs about half the operational cost of that. If you have an electric furnace and you go to a heat pump, you can usually cut your heating cost just by about in half. But this is dominating the market right here. These are called mini splits. Let me show you that. Okay, that's how a heat pump. Oh, I'm going to go back. These are called mini splits. And it is one outside unit, and then you have one of those in each room with a separate thermostat. And those are really, really nice. And I'll explain as I get a little bit further why we like those so much. Standard heat pump works like this. Even when it's cold outside, there's a lot of heat. And you take that heat, you run it across the coil, there's refrigerant in there, you heat up, and it heats inside and then it blows hot air. So it really transfers what existing heat is outside into your home, is how it works. Here's another number that I'd like to have you write down. It's called, if you ever shopping for a heat pump, know this number. HSPF, or Heating Season Performance Factor. You write that down? And it's like gallons, how many miles per gallon you get. And it's the total amount of BTUs that you get out of it by the kilowatt hours input. So the bigger the number, the better. Right now you are served by Pacific Power and they're partners with Energy Trust of Oregon. And so you get incentives for efficiencies. You get incentives. And right now, if you buy a heat pump with an HSPF of 9 or greater, you get money from the Energy Trust. And that's important because people have come up to me and they got an 8.5 and they didn't know about that. And then I had the misfortune to say, guy, if you spent a few more dollars, you could have gotten a better heat pump and you could have gotten incentive money too. You could have gotten incentive money too. And these ductless heat pumps, like this one I was talking about, and I have one right here, it's $800 a house. So it's quite a bit of money. The Energy Trust wants you to be efficient, Pacific Power wants you to be efficient, and even for your own pocketbook, it pays to be efficient. Now I get to talk about these things. I love these things. They're ductless heat pumps, mini split. And the first thing I want to show you is, I'm going to turn it on. Yeah, everyone be quiet here, well, you're already quiet. Did you hear that little beep? It's running. And did you see the vein open up? I don't know if you can feel that. That's it. That is it. And I'll tell you why I like it, and in our office we have 2 sets of them. And we cannot agree on a temperature to save our soul. Some people are hot all the time, some people are cold all the time. We have one lady, and Ange will wear a Snuggie. She will put on the silly red Snuggie when all the rest of the guys are dialing it down and she's cold. But now with a central thermostat, this is what it is, a little remote control. Turn it on and off. Now I've just turned it off. It is that quiet. Why are they so good? They're an inverter-driven compressor. Fancy words, what it means is it only delivers the amount of refrigerant you need. The other ones kind of run like full throttle and then they're off, full throttle on. But this modulates, and so it speeds up like a dimmer switch, so it only delivers the amount of heat and refrigerant it needs. The other thing, there is no ductwork. That has refrigerant lines that go to outside, so you don't have those big ductworks, it doesn't have all those losses. And it has room-by-room control. Now, like in our house, our kids have moved out now. And so we have a heat pump, but I really can't close off a whole bunch of rooms because with a heat pump, you need to move so much air. I mean, it's designed to move so much air, and if you cut off half those rooms, it's not going to work right. It's designed to move that much air through all these. Well, these things, you just turn off the room you don't want. And it has individual control, and it has extremely high HSPF. And that is that heating season performance factor, and that's why the Energy Trust gives you $800 a house. So I really like these things. We bought 2 of them now. I want to talk about thermostats. Thermostats can, make your life very comfortable. And the first one on the left is this one. And this is called a line voltage thermostat. Does anyone have one of these in their house? You guys have some? Okay. One is, you can see the size of the wires here. So let's say, is it a baseboard heater or a wall heater, baseboard heater? Okay. So the energy from that baseboard heater actually goes through this thing. It makes and breaks it. So there's a little caution there because you have, 240 volts available through it. But if you look at they say they are plus or minus 3 degrees. Now what does that really mean? It means that if you set it at 70, it's going to go up to 73 before it turns off, and it's going to drop down to 67 before it turns back on. Most people will say that isn't good enough, especially Angelique. She would say that because it would start being cold. So these work, but some of them do not even have a turn off. They go down to about 55 degrees, and I had this one time I went out and people had a rec room, and for the winter they went to Arizona and they came back and they were wondering why the bills were so big. Well, it doesn't have an off switch on it. It just goes down to 55 degrees. So as soon as it got 55, even though they weren't there, it was coming on. They work, but honestly they're really quite inaccurate. Quite inaccurate. The next one is going to be like this. Richard, where's the rest of these? Can you get the rest? Sure. Here is one that is kind of like this one right here. And this is called a low voltage thermostat, and this is a lot of furnaces. Let me take it apart for you. And you'll notice there's mercury in it. Now what happens as you put the switch, and what I'm looking for, Richard, there should be a low voltage one that is
in a package.
Yeah, in a package. So anyway, what happens, you set the thermostat here, you can see the mercury bubble flows back and forth, and there's a bimetallic strip, so you set it, as the temperature changes, the bimetallic strip, thank you very much, it moves this and makes and breaks and turns it on. And these are better, these will be within a degree. Pass that around. Richard, is there another one?
That's it. There should be 4 up there.
Was there another one that was a digital one like that was? Okay, the final one I want to show you.
Here, I'm sorry, I was wrong.
There we go,
I
thank
didn't
you.
dig far enough in our box.
Okay, good. Hey, I want to show you this. You said you had one in your house that was like this. I got it at Weimar. $39. It's a programmable line voltage thermostat. I love it. I just went and I took that out and I put this. Let me show this to you. I will not trip over this. It was $39 at Weimar, and I set the controls. It's really accurate and has nighttime setback on it too. So you don't have to worry about that. But I really like that.
Can you replace one of the first one, like the first one with something like this?
Yes, you can. One like
this?
The dial one.
this one. Some of them even just say comfort zone. Have you noticed that? They don't even say temperature. But this is a replacement for this one right here. So if you have something like that, you can put that in. It has nighttime setback, a lot more accurate. You're going to like it. $39 by Mark.
Yeah, I've wondered, I've often looked at it, wondering, can I get something that would have better control?
You can do it.
Did you want to see this?
The next one. I love these. I really like this. This is a programmable digital thermostat, and it's used for a heat pump. And ever since and I live in an old house, by the way. Our house was built in 1957. We've changed out the windows, we've insulated, but still it's not great. There's only a R7 mat, not much insulation in the wall, but we put in a high efficiency heat pump. The main thing was it was cold all it seemed like at the time. We put in this and it has stayed within a half a degree. It is locked on. And it's called a learning thermostat. And I didn't even know there was such a term. And when the contractor put it in, the first day I said, because I go to the gym in the morning, and I said, I want it at 65 when I wake up in the morning. It was only about 59. And I go, Bob, hey, this thing isn't working. He said, Buzz, give it a day. It'll figure it out. And I said, what do you mean it'll figure it out? And what it does with a learning thermostat is, let's say you want to set it, we like our house a little bit cold at night, to drop it down about 55. I don't know how you guys are. We like it about that cold. And then in the morning, it starts coming back on. Well, and I said I wanted to have 65 in the morning. Well, it didn't make it. So what the little computer, it says, well, to get it at 65 and to do that by 5:30 in the morning, it had to start at about 4:30, to warm up. It didn't make it. So then it starts 15 minutes earlier. And if it doesn't make it then it starts 15 minutes earlier till eventually it hits it on the button and it hasn't missed a beat since. So I really, really like these thermostats. And they also work well with heat pumps, because heat pump, you really don't want to bang it on and off. They don't work well that way, because then the strips come on and it's no better than a regular furnace. With these, not only that, it'll ramp it up slowly with the heat pump, so it recovers with a heat pump rather than the strips, and you're losing all your savings. So really, really like that. That one, by the way, is my favorite, and I really can't give, all I can say, that's a Honeywell 8500. I love it. I love it.
Buzz, before you move on, how hard is it to replace those in a home?
On this, I'm kind of handy, like on the one she was talking about, that line voltage one, I did it myself. If you're handy, in Oregon, you can work on your own electrical system. Never put yourself in jeopardy. If you're unfamiliar with it, have somebody that's familiar or a licensed electrician do it. I do this all the time. Todd, I did that in 10 minutes. Took the old one out, took the wire nuts on, put it in, put it on there, and I was good to go.
It's basically wire nuts that you're dealing with.
Pardon?
You're basically dealing with wire nuts, basically.
It was all wire nuts. It was. I just took the wire nuts off, put the new one in, and I was good to go. Here's another thing I'd like to have you guys write down. Every degree over 70, this is a rule of thumb, raises your heating bills about 3.1%. So if you had it at 71, your bills are going to be about 3.1% higher than if you kept it at 70. If you kept it at 80 rather than 70, it's going to be about 31% more for heating. And the reason why, it's not only the heat in there, it's the heat loss of your house. There is a bigger temperature difference now between the outside and inside, and when you do that, the physics of it, you move a lot more heat through your windows when there's a bigger temperature difference. Okay? That's why that happens. So, every degree over 70 in your heating season raises your bill about 3.1%. Okay, here's my pet peeve. By the way, this is Lakeview, Oregon. And I went there, it was a commercial building, not going to say who it was. They said they needed a brand new heat pump. I went there to look at it, explain the energy trust incentives. I went up in the attic, and that's what I found. That is their return duct. That is a 14-inch air duct, by the way. That was the return, and it had fallen off. And you know what? I've been around here long enough. It gets cold in Lakeview. And no wonder they couldn't keep it. They were pulling that cold outside air into the attic and running it through that heat pump, and they were freezing, and their bill were $800. It was about a 1,400 square foot, commercial building. Here's the problem. You cannot see this metal ductwork here, and that it was just duct tape. You can't do that. You can't do that. If you're in a crawl space, which is no fun, or an attic space, and it's all dusty, and you're trying to get that duct tape to stick, it doesn't stick. So the way you do it is you put it on there, and then you use sheet metal screws with big fat fender washers, bump, 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 and then you can duct tape it. Or you use a thing called a Panduit connector. It looks like a zip tie. You guys know what a zip tie? And you put a zip tie around it, and you crank on that thing. It gets about 2, and you just can't pull them off. Either you put it on with one of those zip ties, or you put big fender washers and screws, and then you tape it. But this is epidemic. In half the places I looked now, it has fallen off.
The name is misleading.
Pardon?
I'm just gonna defend us and say, the name is misleading.
It is.
I mean,
It is.
What, duct tape?
I'm right.
It is. It is misleading. Yeah, so here's another one. You know where that was? Our office in Medford. Ross was right next door, and and he's going, God, Buzz, the sun, I'm just not getting good air conditioning. I go, okay, this is my own office. And I look up there, and you can see it's a T-bar ceiling, with tile. And this is what happened. And I think it might have been when the cable guy strung the wire in there, he might have hit it, but it was just taped right onto there and it was off and nothing. It's everywhere I look now. So one thing, another one is in your own houses. In your own houses. You know, turn on the fan and go around. Can you feel the air coming out? Can you feel it? And if you can't, even if you just take your foot and take your sock off, and are you getting air out of it? If you're not, have it checked out because you're heating your crawl space. Here's another story. This is this was a trouble call that I had in Medford in a trailer park. The lady had a double wide. So that's one side here, one side there. Now if you have a double wide, they're connected by a thing called a marriage duct. It connects, well, because the furnace is on one side, on the other. And I go in there and it was a lady was a little bit elderly in there. She's sitting in a chair. The bills were too big. She was unhappy. And I could see right off the bat, it was coming out of one side, not coming out of the other. I'm sitting there talking to her and I said, you know, you don't have skirting around your manufactured home. And animals can get in there. And if you're a cat or you're a possum, what do you want to do? You lie on something warm. Yeah, I don't care if it's your dryer or the hood of your car. The next thing you go, and pretty soon they're inside it. And all of a sudden I looked down and right next to it was the register and I saw some eyes there. And I pulled it was her cat. And she goes, and I pulled the cat and she goes, Tabby, I haven't seen you for 3 days. And the cat had gone all the way in there and then could not turn around. So anyway, we saved the cat, but anyway, there is a huge metal marriage duct between one side and the other. If you live in a manufactured house or you have any kind of, it's got to be closed off. If animals get in there, they will tear it apart, especially on the flex duct because they like to claw. Okay, did you guys see this ad? This was in the Medford Mail Tribune. And what it was, save 50% on your heating bills. Oregon residents set to get new infrared heaters to save up to 50% on their heating bills for $99 if you call now. That's what it was. You know, we have these call centers in Utah and stuff, and we get these calls because people say, I bought this thing, my bills didn't go down. Well, I read on this thing, and the one thing they will do is say it's supplemental heat. But it's good for a house up to 1,000 square feet. I'm going, what? In Oregon, you use one of those in every bedroom. In every bedroom. It might be 1,000 square feet if you're in Maui, but it's not going to work in Lakeview. Here's the answer. This is just straight physics. 1,500 watts is 5,120 BTUs. 1,500 watts is 5,100. It doesn't care if it's infrared, convection, when they're all the same. They're all, now if you feel a little better because that's red and you like seeing red, that's great, but they're all the same. Don't let anybody sell you that. They're all the same, okay? And they can be effective if you stick one in the bedroom and you want to just heat that bedroom rather than the whole house, but don't try to heat your whole house for that thing. So they could easily raise the bill $90 to $120, no problem. No problem, they're all the same. Here's another one. I went to this, and the reason why I went to this, we get trouble calls, and by the way, we're there for you. You're going to get our phone number. That we are a resource for you. Pacific Power is a resource. We are a resource. Energy Trust is a source for energy efficiency. You can call us if you have any questions. This came out of Grants Pass, and I knew the people, and the father-in-law of this lady went to this event. And you can see, do you see this foil he has in his hand right here? What they sell you is they cover their insulation with perforated foil, and it's reflected. So he says it'll cut 60% of the heat loss of that. And so they put it on top of your insulation and below the floor, and then they put compact fluorescents in, and they put an attic fan, and they charged him $10,000. His house was 3 years old. And the guy signed the contract. We took it to our attorney. We have an attorney we could not get him out of the contract. But you know, he drank the Kool-Aid, and we could not get him out. And you see, the thing is, with current code houses, 3 years, there isn't that much left to save. There isn't that much left to save. If it was a house with no insulation and anything like that, but you know, here's just numbers. If you have 6 inches of insulation, if you have no insulation at all, you lose 36 BTUs per square foot per hour. If you have 6 inches, it goes from 36 to 3.9. Drops that much. You go to 8 inches, it goes to 1.6. He only had 1.6 to start it with. So, I mean, you're wrapping doorknobs. And he got took. So my little message, and we have these take-home messages, if it's too good to be true, it's probably too good to be true, especially if they offer you a dinner to go. Okay? Things that I do really like, there are some very, very legitimate energy-saving things out there right now. One, front-loader washers. I got in this because I told you I live in a farming community. It was Sunnyside, Washington. We were on a septic tank. If you're a septic tank, you're a lot more conscious of what goes down the drain. A front-loader washer uses 1/3 the amount of soap, 1/3 the amount of water, and 1/3 the amount of energy of a top loader. And the other things is this other one, is they spin so fast now, we get some clothes out of, like your shirt, sir, would almost be dry coming out of it, because it just blows the moisture out, so your dryer doesn't work as long. Your dryer does not work as long. They are a true energy saver. We got into it because the fact we didn't want all that stuff going down our drain field, and a problem with our septic system that we had. There was another thing too. My wife works at a company, I don't know if you've been there, it's called Healthway in Medford, and they're an herbal thing. She's really kind of an herbal wizard, kind of a witch doctor, but I love her anyway. And so she works at this place, and the ladies all there were given a shirt. And about 5 years later, they all were going to take their picture, and they're all, there together, and Sherry's out there with a shirt, and the lady said, "Who gave you the new shirt?" "Who gave you?" She didn't. She said, "It's my same shirt." But she was the only one with a front loader washer. And if you ever go to a commercial laundry, not a laundromat, because those will be top loaders, but if you go to Aeromark, one that does hospitals, they're all front loaders. So one of another take-home messages, if you're ever in this situation and you're shopping for one, they are worth it. It helps on your drying, helps on your washing, saves energy, really worth it.
Why? What's the technology that makes them so different?
Instead of an agitator, first of all, the amount of water is, they just have a little puddle of water and they, just dip the clothes, dip the clothes, dip the clothes. When you talk about an agitator, you fill up the whole tank and then you go back and forth. And so it's 1/3 the amount of water is right off the bat. Also, they use a if you ever have one, they use an HE detergent now, which is non-substitute too. It's the technology of, they're not as hard on it. It's technology of not as much water. Technology of they spin it so fast that drives the water out. We love them. The other thing, and I'm older, by the way, I'm 67, and I don't enjoy stooping down as much. And the other thing we did on ours, we put the pedestal under it to raise it up a little bit, and I really like that too. Televisions. There is, I'm not saying what's on TV is good. There's a lot of trash on there, but that technology is phenomenal. And the hottest ones out there right now are the LCD, that stands for liquid crystal display, and LED is the background. To make the blacks black and the whites white, they have lights in back of them. It used to be fluorescent, well they've gone to LED. And the LED has really reduced the wattage of it. And it is amazing, and Samsung has been leading the charge on it. This is a 55-inch set, and the reason why I chose it, I have this set. And I put this power meter on it because I couldn't believe it. When I turned it off, I actually got no power. Now that's strange because, if you have a remote in your hand, it's got to be using something because, the receiver has got to be doing something. I could not measure it. It was less than I could measure. Less than I could measure. You'll see this tag on it. You might know where that tag, I'm not going to give a plug because wherever you buy it, but the cost to operate this 5 hours a day, 365 days a year, at 11 cents, which is what you guys pay, is $11 a year. That's how cheap they are now. Here is the range on television like it from 2473. You see where the arrow is down here? It is lower. Samsung has been leading the pack. LG just beat them. I just checked it yesterday. They have a 55 now that does it at instead of it's $10. I mean, live big. I mean, you know, who cares, $10 or you can't buy a movie ticket for that, you know. So there have been huge improvements on that. TVs right now, the most common are the HD 1080s. That is, the 4K is coming out. You've probably seen that. One thing I need to tell you about the 4K, they don't broadcast it yet. So if you buy that, you are ahead of the curve. Another thing that I would say is, and if it's too technical, just stop me, you know, is that when you look at the frequency on it, first they were 60 cycles, then 120, and now 240. And it's how many pictures you're taking a second. If you're really, and what happens if you get a 60 cycle set, and let's say you're watching football and the guy goes back for a pass, he throws that pass, you might see it kind of strobe a little bit. You go to 120, it doesn't strobe anymore. It looks like, you know, a football pass. Or you're watching NASCAR and they're going faster. So somewhere around 120 cycles, 1080p is a good way to go. And I really like some of these products, especially because the energy savings on it. It's inexpensive entertainment in today's world. One of my favorite subjects is lighting. Right now, nationwide, about 30% of all the energy used in the United States electricity goes to lighting. 30%. But in your house, it's only about 10%. And that's interesting because a lot of people still come in and say, hey, I got to pay my light bill. Well, it really isn't your light bill anymore. Most goes to the water heater, it goes to the electric heating, or it goes to appliances. But we still call it your light bill. Well, it's even less than 10% now because what's happened in lighting. And this is what's happened. We showed you here just a standard incandescent light bulb, didn't we? And then we went to CFLs, compact fluorescent. And by the way, let's take, how many just hate them anyway? Yeah, that's about the CFLs, the twisted. You hate them, that's good. It's like, most people don't like them, you know, it takes a while to warm up.
It's a different color light and it's not as strong.
I want you to hang on to those words. Yeah.
I was gonna say, they don't last as long as they advertise.
They don't last as long.
That's true.
Okay, hang on to those words, this is perfect.
Because now he's gonna prove us wrong, right?
Well,
No,
I
I'm
have
a
real world
totally right.
experience.
And it's in the advertising it. But let's compare. Here's a standard incandescent bulb, here's the CFL, and here's the new LED. Now, the big thing about the LED is the hours. Remember I said these only last 750? So incandescent, I'm comparing 60 watt bulb to a 13 watt CFL to a 9 watt LED. So incandescent runs 750 hours. Can you guys see this? Is it okay for you guys? The CFL, they say, is 8,000 hours. And the LEDs are 25,000 hours, and they're doing better than that now. So by the time this one burns out, I've gone through 33.3 incandescent bulbs. Do you see the math on that one? And I've gone through 3.3 of those. And then my cost is about $6 for an LED, $5 for that, and I've got $20 for 33 of those, okay? So now, here's the energy, 1,500 kilowatt hours, 325, this is how many I've used. At 11 cents a kilowatt hour, I've spent $165 there, 36 there, 25. Total cost, now if I look at energy and the bulb, it's at 185 for the incandescent, because I've replaced it 33 times. Are you tracking with me here? I've replaced this one now 3.3 times. So I've got 185, $40, and 31. And so you can see what's happening now. LED is dominating the market. Dominating the market. And it's all due to these guys. This is a Russian physicist, and Losov in 1927 created an LED. LED means, diode. It stands for light emitting diode. And what this guy did, he was experimenting in his Russian lab, and he was running this semiconductor and electricity through. A diode is a one-way electrical valve, by the way. And they put this impurities on it, and it was starting to glow. It was, started to glow. So now it was a light emitting diode, and that's where the word came from. He invented it, but this guy, Holonak, over here on the right, he was a GE physicist, and he's the one that really commercialized it. And now they're everywhere. Christmas lighting, regular lighting, and they are everywhere. But there's one thing I want to caution you about. is this. Used to be, you know, my wife would say to me, you know, I'd say, honey, when you go down to the store, say, pick up some 60-watt light bulbs. And that was it. Well, now is it, well, do you want regular light bulbs? Do you want halogen? Do you want CFLs? Or do you want LEDs? Or if you want LEDs, what brightness and color do you want them? I mean, it's confusing to even get a light bulb. But I want to show you this why, because it is important. So look at this. Here is a standard light bulb right here. And the color is right here. See? 2700 Kelvin. Kelvin is a temperature. 0 Kelvin is like 270 degrees, but this is kind of warm. It's kind of a yellowy warm. Now, what I've done here, this is the equivalent in an LED. Well, look at this one. Would you say it's pretty close? Pretty close. Now, here's what I don't like. People are buying these ones called daylight. Now, look at that. Now, it has a huge bang for the buck. But when we remodeled our house, I decided, because it has such a bang for the buck, I put them in our bathroom. And it was all around there. My wife goes in there, puts on her makeup. I swear she looked like the bass player out of Kiss. It was not pretty. She said, get those things out of there. But you can even see what happens, and I'll turn them off. Watch this. You can see, even if I put my hand behind it, can you see it's pinky warm? Pinky warm. Definitely blue, white. So when you look at them, what I recommend, if you use them inside your house, I really like the 2700 Kelvin, because it gives that warm look. Warm look. I have used these, you know where I have used those things? In my basement and in my crawl space, because you get, did it look really bright to you? Oh, by the way, this was 60 watt, that's 9 watts, that's 9 watts. They're just 9 watts each. So they're energy efficient, really, really energy efficient. But you gotta be conscious. And this was a trouble call I had in Bend. It was a dog washing parlor owned by a lady, and she put these into her vanity, because the reason why, have you heard about, and I always get this screwed up, by the way, it's people that have an aversion to darkness and they need, what's it called?
Seasonal effectiveness?
What is it? Seasonal effectiveness, thank you. That is it. And so she looked at these ones, and, hey Richard, do you know where the box is for that says what the ones, it says daylight on it. So she's thinking daylight, wow, that's good for seasonal defective, seasonal, what'd you call it?
Effectiveness disorder.
Effectiveness disorder. And she was thinking it'd be really, really a healthy thing to have it. But what it's really referring to is not that. It's referring to that. See, on a blue sky day, it's 9,500. So it's just getting really, that one is 5,000, by the way. So it's right into this blue-white category. And you get a very big, thank you, Richard. These two right here, thank you. Thank you. And you can see, right, this one says daylight, and you can see it blue. Cree is a wonderful light, by the way. But here's the one I like, and you see it's warmer. And I'll pass these around. You can look at the color on the back. See, this one says 5,000. And that one's 2,700. So if you look at LED lights, by the way, be very cognizant of what the temperature is and how you're going to use it. And the blue ones have a place, I'm not saying and the reason why they have such a big impact, if you look at the rods and cones in your eyes, what has the biggest impact is that color. Have you guys been driving down the I-5, and all of a sudden you see some cars, a lot of the younger guys have them with the xenon headlights? Whoa! I mean, you see them, they look like a demon coming in. They'll be a mile away. You see them along your eyes. They're not if you put a foot candle in front of it, not any more than anybody else, but you perceive it. Blue, white. If you see a police car, what color do you see first? It's blue, because you perceive it. Why does the military put a flash suppressor on the M16s? To get rid of the blue. That's why they do it. So anyway, as you go check them, another thing you have to find out now is what color do you want, honey, when you go out and put that in, okay? The most misunderstood thing out there, and why 9 out of 10 hate them. They do have a purpose, but here's the thing. They are now designed to fit in a standard socket, and that's good. They have good efficiency. They do have a long life, but here is the caveat that they never tell you. It's based on a 3-hour runtime. Based on a 3-hour runtime. They hate on and off. If you put this into your, like a closet, and you go in there to pick out let's say a blouse, you turn on the switch, first of all, it doesn't come on, it's slow to come on. Then you go get your blouse, and you go and you turn it off, you just shot it in the head. They want a long runtime. So I did a little study on this, and this is what I did. Came here. This is Sylvania's, I copied this right out of Sylvania's large lamp catalog, which has everything from stage lights. And look what it says on the bottom, this is footnote 2. This is for the life ratings of fluorescent lamps are based on a 3-hour burning cycle. How about that? It doesn't say that on the box. It doesn't say it on the box. Because a lot of people expect 10,000 hours and you go, hey, thing's dead in a month and a half. It was supposed to be 10,000 hours. I'll go back to my mom again. I was telling you how, she was too old to get up on a chair, and first I tried the dimming lights. She hated those. And eventually I did put in compact fluorescent, and I put in once, and the reason why in her kitchen, when she had hospice and everything, those lights were on 18 hours out every day. The run on, and I got 3 years out of them, because they hardly ever went off. But you start turning them on, turn them off, turn them on, turn them off, they're not going to make it. Most misunderstood out there. We have some things that are a real advantage. And one, because you are served by Pacific Power, they are partners with Energy Trust of Oregon. And this is the number, write down the phone number please. And it is 866-368-7878. Or you can go to their website, energytrust.org. Just put that in, it'll go to, and you can go to there and you can see what money they will give you. Like if you have a refrigerator, let's say I have an old refrigerator out and back, and you think, wow, I need to take that thing. If it runs at all, I think it's currently, they'll pick it up and pay you $30 for it. Or you can take it to the dump and they'll charge you $25 to get rid of it. So, I mean, they are very, very conscious about it, and they're a partner with Pacific Power. Oh, I want to tell you this. They also have a free kit for you, too. You fill out a questionnaire, and they send this to your house. And it has LED bulbs in it, shower heads that are reduced flow, faucet aerators, and if you go to the same website and you look at Energy Saver Kit, you fill out the form and they send it to you in the mail. They send it to you. And the last one out there is us. And company, we have the Oregon Energy Green. We do utility services, we do training, we're troubleshooters. And our number is really easy. You can call. I work with Richard and I work with Amber back there. And this is what we do. And if you guys have questions, give us a call. And our number is, it's almost like a rock station. 541-200-2000. Call the next 10. And that is our number, 541-200-2000. And you can ask for me, I'm Buzz. You can ask for Amber, you can ask for Richard. Any of us are happy to answer your questions. And that's where I am right now. And I am very happy all you guys are here. Thank you very much for showing up. But if you have any questions at all, I'm happy to entertain them. Yes?
Tankless water heaters, how do you feel about that?
About what?
Tankless water heaters.
Tankless?
Or I guess they call them on demand.
Yes. Okay. And are you talking electric ones?
Yeah. Because I actually did the Energy Trust, which is awesome, by the way.
Yes.
And I had my contractor come and do check out the house. I have a coworker who got a tankless, or whatever you call it, and she loves it, and she swears she saved power. That was the only improvement she made at that time. And the contractor said, you don't want that. So I'm just wondering, I don't know why.
Okay. It's very good.
I would love to have that closet for something else.
Okay.
No,
Space.
I live alone now, and I kind of thought because I'm using it in the morning and at night, then of course I would save tons of energy, but.
Here is the answer, okay? A standard water heater like the one that I have over there, well, even if you didn't use any, it loses water, it uses energy in three ways. One is to fill it up. You have cold water in, you gotta heat it up, right? Two is when you use water, let's say you take a shower, when you use water, cold water comes in, and And what's hot water goes out. And so you have to have energy come in for that. Okay, so I've got energy there, and the third one is to keep it hot. In other words, even if, let's say, you go on vacation, you got 50 gallons of water that's going to be hot. It takes energy to do it. So I put a meter on it. Went to the meter shop. It costs, if no use at all, 100 kilowatt hours per month just for it sitting there. Okay, and 100 kilowatt hours is $11 a month, just it sitting there. So when you go for a tankless, what are you really saving? You're saving some on filling it, you're saving some on maintaining it, but as far as the use, it stays the same. I mean, if you take the same length the shower, it takes, one kilowatt hour raises 4.1 gallons, 100 degrees Fahrenheit. Okay, that's the math. So whether you do it with a tankless or not, so is it going to cut it in half? No. It is going to save some energy, but the big concern I have is this, is if you don't have 50 gallons of water right here, and let's say you just have a small tankless, you've got to have a lot of electricity going to it, because if you don't have that volume of water, you know, the elements, instead of being a 4.5 kW, they've got to have a lot of them in there. Your panel might not be big enough to even handle it. What did you see an electrical contractor?
No, well, I guess, it's seasons change, I guess they do all of
Yes.
that kind of stuff. But there was something with the connection, I think.
Okay.
So basically, I got the impression that the initial install would obviously be more expensive.
Yes.
But, okay.
I would be very cautious. I'd be very cautious. Now, I'll tell you something that we've done in our house that, and it isn't, and a tankless, I mean, they are small. They're about the size of a lunchbox like that, and you've got big wires going into it. The water goes through and it flash heats it and comes out. I mean, that's how it is. I've done something else in our house, and let me show you what our house looked like. We live in a ranch style house. House is long, like that. Shower is here, water heater's here. It takes 3 minutes just to get hot water there, whether I'm at the sink here to wash, shave, or it took 3 minutes. And I got tired of it. I mean, whether to wash my hands or shave. And so what we did when we remodeled our house, I put a small water heater, it's only 10 gallon, right underneath the floor, right here. And so I'm no longer waiting. If I go to the sink and wash my hands or have to shave, I have it there in 10 seconds. It's just bang right there. And because look at all the energy I wasted. I had hot water coming I should really do this in red. I had hot water coming out of this thing, just all the way there just to shave. You don't need much hot water to shave. I lost all this, and that would happen 3 or 4 times a day. I would lose that. So the way I saved energy, I put a smaller water tank, and this one only holds 10 gallons, so it's about this height, like that. And I still have this one. I have cold water coming to this, and I have hot water coming out, and it just serves that sink. The shower, I still have to wait 3 minutes because my shower is more than 10 gallons. But that's what I've done. And also the wiring on it's simple. It's just a standard, 220 on it. And so I didn't have to change my panel. I didn't have to. When you start about talking tankless, unless you're talking gas, you're not talking gas, right?
No, we don't
You don't have
that
gas. That you're talking about usually substantial work to your panel. I'd be very cautious.
Okay.
That's an excellent question. Any other questions? Okay.
So you refer to these as mini splits. Is that a mini?
What this would do is,
But is that a mini?
it is a mini split, right? It's called a mini split because outside you just have that one unit. I'll go back to that.
Right, oh, no, I understand,
And this goes in every room.
see, okay.
It goes in
I
every
mean,
room.
I have a small house,
Mhm.
but that's what they're recommending.
That is what they're
Something
recommending.
about that, so, yeah.
I love it.
When you say
For the whole
every room,
house,
so if
though?
you have a 4-bedroom, front room, family room, kitchen, et cetera, you have to have one of those units in every room?
You would. You would. Now, if you had one, let's say you have a great, let's say your living room and your kitchen's all together, one will do it. And then this is a fairly big one, then they have the smaller one that would go into, let's say, in your bedrooms, right, like that. And some of them can go up to 5 units. And some of them are disguised too. I've seen them worked into the woodwork so it isn't out there. And usually they mount it higher up on the wall, is how they do it.
Which is nice if you have 10-foot ceilings, but if you have our little houses in Lakeview.
Well, it's also nice, excuse me, because furniture moving, you know, to have it up there, you don't,
Get it out of the way.
but I mean,
But
there's,
what does a system like that cost?
it depends. We had one put in, it was, I think, $9,000. It was a little bit more than a standard, but I had air conditioning and heating and high efficiency and control, and that's pretty nice.
For how many, the split unit or
I-
per set or
I had 4 units put in.
4 units for 9,000? So if you felt like you could do one room,
If you do just, let's say you only need one room, they make it all in one. It goes in the wall and all the stuff's on the back. It's called a P-TAC, which in other words, there's a heat pump on the back and it's all built into one, if you just have one room. But if you have multiple rooms, let's say, like if I built a brand new house, this is the way I did it. I would do it this way. You know, they almost go down to about 20 degrees, and you know, they go down really, really low. And it is so quiet. You go outside our place and you listen to that. We've had people, is it even running? They've had these in Europe for 20, 30 years. We're just slow to get to it.
That's what I had in Germany.
They call it a mini split heat pump.
do different manufacturers, like, these go down to 20 degrees, some market for a warmer, like Medford, and some market so that they will handle a colder temperature?
Yes, they do. Some of them have a little heater in them too. So let's say, because I know your design temperature is colder than Medford. And Medford's 27, and I think you're down like a 20. You guys are colder. And so sometimes they'll put a little strip heater in there in case it really gets cold, that it can give it a boost. I really like them.
So the single one was called what? Heat?
It would be a PTHP. It stands for Package Terminal Heat Pump. PTHP. And it's strange I can remember this, and I struggle to remember my wife's cell phone number. But that's the single unit, and this one they call a mini split because you have one outside unit and 4 of these heads.
So the
These
single
are
unit,
these are all really good questions, by the way.
I'm sorry, does the single unit still qualify for that, the $800 per house?
No, it doesn't. I'd have to go to the website. It does qualify for some, but I don't know. I don't know. It's the mini split system. I know it's for $800. So
So do you have an idea what the price is on the PTHP?
you'd have to get it priced, and the reason why they're going to size it for, you know, the size of it. They have bigger ones.
Oh,
I've even seen some of these used for motels.
They installed them in the annex in Christmas Valley.
Did they?
And they're, like, you're right, you can't hear it, the temperature's always comfortable, but it's a little square, each office is just a little square room, so it's
Yeah.
hard to, you know.
But it's nice to have that control.
Oh, it is. Yeah, I just walk in.
Click. You're there.
On.
It's very nice.
Here today.
Any other questions? Well, everybody, I sure appreciate taking your time, and I'm
Yeah.
going to turn it back to Todd.
I was just gonna say, Buzz, thank you so much for everything you've done tonight, and you did an excellent job again. I did learn something new again.
Woo!
So every single time I listen to you. If you're sitting there saying, God, you know, my neighbor should have really come tonight to see this because
Yeah.
this was a lot better than, well, they have an opportunity. They're just gonna have to travel about, 90 miles to Klamath Falls, because Buzz will be there at the Ross Ragland Theater tomorrow night between 6 and 7:30 doing a presentation there. So if you really encourage your neighbor to do that, they have that opportunity to go there. This is the first one out of 28,
23, I think.
23 presentations Buzz is going to be doing throughout the state. So you guys are leaders, if you want to think of it that way. And Buzz, again, thank you so much. You do an outstanding job for us.
Thank you very much. And Amber is passing out something we'd like to do. This book is a wonderful book by Pacific Power. And it answers everything on how to read your meter. And also, Amber, we have that little questionnaire.
Yeah.
We'd really like, you could take a moment and fill out that questionnaire, the green one. You could just take a minute doing that, and Richard, I believe we still have food back there, or are you?
Yes, we still have food. I just
Wow.
snagged a cookie.
You were going through that like a Hoover.
Dinner while it's in.
Thank you.